fascinating internal combustion engines in the past, and you can check out those videos via the links in the description later. Today, however, we're going to talk about 3 free piston internal combustion engines that could revolutionize the industry. Let's dive in. Many contemporary advancements in internal combustion engines aim to reduce their size and weight, facilitating their integration into hybrid vehicles. A new development from the Center for Energy Research showcases a free piston engine that serves as a generator in a hybrid car, providing electric power to both the battery and the electric motors. Structurally, the engine consists of 2 oppositely located cylinders housing 2 interconnected pistons. Between these pistons, a linear motor generator is situated. This motor generator has dual functionality. It serves as a starter initially and, once the engine is running, it generates electricity. The declared efficiency of this engine ranges from 40 to 50%. The increased efficiency is largely thanks to the removal of unnecessary components. For instance, there's no crank connecting rod mechanism in this design, and motion is directly transferred to the linear motor generator. Lateral friction, a common issue in standard piston engines due to the connecting rod angle, is also reduced. The absence of bearing supports allows the engine to operate at a higher compression ratio, and the piston speed from the top dead center is higher, decreasing heat loss. Furthermore, tests have shown a reduction in harmful emissions by 15%. The end result is an engine that's significantly more efficient, cheaper to manufacture, compact, and easy to maintain. The operating principles are similar to those of conventional engines, meaning that massive funding for research is not required. Plus, the piston's position can be adjusted, thus varying the compression ratio, which also enhances efficiency and allows the engine to adapt to different types of fuel. The cooling system can also be downsized due to lower heat generation. The presented Mark V prototype includes 4 pistons with a total volume of 800 cubic centimeters and a power output of 24 kilowatts. Essentially, it is 2 free piston engines working in opposition to each other to compensate for vibrations. This motor is comprised of 2 linear generators, 2 spark plugs, injectors, and valve casings. Based on visualization, it operates on a 2-stroke cycle. A unified cooling circuit is used for both motors in the system. At the top, we have an intake manifold, with the exhaust situated at the bottom. The prototype itself is rather compact, just 50 centimeters long, 20 centimeters high, and 21 centimeters wide. Many car manufacturers are also seeking solutions for maximally efficient internal combustion engines. This is why a major car manufacturer like Toyota is developing its own free piston engine. The goal is similar to create a compact generator for a hybrid vehicle. This is the first prototype that Toyota has told us about and tested. This is a single piston, 2-stroke engine with a linear generator and a unique W-shaped piston. Let's first look at the structure. On the left, we have the combustion chamber, and a coil is located in the cylinder wall. Here, a permanent magnet is positioned on the piston. When these components move, energy is generated. The W-shaped piston structure, depicted in brown on the diagram, is designed to compactly accommodate all these elements. At the back of the piston, there are 2 gas spring chambers. This means that the piston will compress the gas during operation, and thanks to the pressure created in the chamber, the piston will return to its original position. Now, let's consider the operating principle. There are 2 strokes. First, we see the power stroke energy is generated. Then, at the bottom dead center, the intake hole and the exhaust valve open. At this moment, the system is flushed, and the cycle repeats. After the power stroke, the piston must be returned and the air compressed. For this, there are 2 gas spring chambers. During the power stroke, the gas is compressed. Afterwards, the piston returns and compresses the fuel-air mixture. Toyota conducted tests and the engine operated for several hours without issues, with a fairly high efficiency of 42% and outputting 10 kilowatt of power. The plan is to use 2 such interconnected engines in hybrid cars, which will be more than enough for the vehicle to consistently maintain a speed of 120 kilometers per hour without recharging. As we know, Toyota won't widely show off new technology until they've thoroughly tested it, so we'll wait and see. Now let's continue, but please, don't forget to like this video and subscribe to the channel. There's a third variation of the free piston engine from Aquarius Engines. Structurally, this version appears maximally efficient, as there is only 1 piston, 1 cylinder, and 2 combustion chambers. This engine has a minimal number of parts. A hollow rod runs through the entire engine, where the piston, which divides the cylinder into a right and left combustion chamber, is located in the middle. There's also the engine block, and on the sides are 2 cylinder heads and 2 bearings. The intake holes are located within the rod itself, opening and closing with its movement. Meanwhile, an exhaust hole in the middle of the cylinder wall opens when the piston transitions to the other side, thus allowing much more time for engine scavenging. As a result, we get minimal friction, a minimum of moving parts, correspondingly high efficiency, a weight 6 times less than a comparable traditional engine, and a power output of 30 kW for such a compact generator. Production of these stationary generators has now been launched, and they will begin to be used in cars in a couple of years. Please write in the comments what you think about this and subscribe to the channel.